Hello everyone, and welcome back to another video. Sorry about not posting anything for I don't know, a month or two now. I got lazy. I was just playing games all the time, streaming, all of that. But I also did have to do 2 of my final exams. And I finished. We'll be graduating this Friday, which is very nice. It's not really an excuse because again, I got lazy, but it is what it is. At least I'm back. So with the videos I've done, I've pretty much completed the linkless side with the single and the double. There is still one more linkless, which is called the circular. A circular linkless is like a linkless where the last node, something like this, it's gonna point back to the first node. So in a way, it looks more like you're creating a circle, and it just loops back. So let me draw it out, something like this, right? So yeah, it's gonna just form like a closed loop instead of having the last node point towards a null. So the structure is that all nodes are connected in a circle, and if you keep following the next pointer, you'll eventually come back to the starting node. So this allows like continuous traversal on the list. And it's a little bit different from like a regular linked list because in a regular like single linked list, the last node's like next pointer is towards null. So for a single linked list, they'll point towards null like that. But for this one, and it sort of tells us that we've reached the end for like single, and same with double. But in a circular linked list, the last node next pointer points back at the first node, which is the head. So there is no null at the end. And so, it's something like this, like a circular linked list. What is it really good for? It's good for like, let's say a multiplayer game where it's like a turn based for player 1, player 2, player 3, and then back to player 1. So circular would be good. Or maybe like a repeated music playlist or video playlist, and if it loops back to the beginning once it hits the end, that's also circular. And so for the types of circular linked lists, we have 2 of them. The first one, which is just a single, and let me write it slightly more in detail. So we have a node with data and the next pointer, data and next pointer, data and next pointer. Now, this would be considered the last node. However, instead of pointing it towards null, the next pointer will be pointing back towards the first node, or the head. And that would just be the single linked list. For the circular double linked list, it's very similar to the regular double linked list. I'm just gonna write it out real quick. So the P stands for previous or prev, D for data, N for next. Which is a lot better that way. Data next. So again, same thing. The next pointer will point at the back at the first node, and then it's similar how to like a double linked list work. You have the previous pointing back for all of them, and then we also have the very beginning prev. This one will point all the way back to the last node. And so when you look at it, it forms like a circle around, and then within you can still travel from prev and next. And I think that's pretty much just about it. And like when it comes to traversing a circular linked list, because there is no null at the end, we cannot use the while statement, or we can't use just the while statement. So usually when I want to traverse through like a single or double, I write something like while the current, which is usually the current would be like the pointer that is equal to head. So I would have something like current equals head. And on the bottom, it'll be while current is not equal to null. So when this happens, you're basically traveling through the linked list. But because there is no null on the circular, whether single or double, instead of doing this, what we do is we are just gonna sort of like go around the circle once. So same thing, you keep the, where's the eraser? There we go. Okay, you keep the current equals head, but instead you want to do a do, and then just visit the current, obviously. Now visit the current just means that like you can print the data, you can count the nodes, blah blah blah, all of that. And then have current equals current.next. And I'm just gonna write cur to make it some easier. Like that. Current.next. And then after that, you do while current is not equal to head. And that's it. So what it's going to do is, obviously, the first node is the head. And it's going to look at the current first, look at the data, count the node, whatever it is. Go to current.next, and then continue while the current is not equal to head. So when it comes back and the current is equal to head, then this basically stops. And that's how you travel through a circular linked list. You just want to do it exactly once. And okay, now I'm going to try to write out the code for it. Okay, now we're on to the part where we're writing out the code. I already have the test case written out. And what we're doing is just the circular single linked list. If it's circular double linked list, it is very similar to a normal double linked list. So you don't need to worry about that. I'm just gonna write the circular list out and just have like 4 different like we're gonna have the add, the print list, the delete by value, and the search. So let's do this. Okay, so static class, we're gonna call it cnode. We're gonna have int data, cnode next, and then cnode int data. Oh, let's have some space. And this dot data equals data, and this dot next equals no. There we go. Now, this is just for a single linked list. If it's double, we'll have a prev or previous. Anyway, exit cnode head. This is the head, points to first node in the circle. Nothing else. Now let's do the add function. So add to end, and we'll call it tail. Now we're gonna have public void add for int data. So cnode new node equals new cnode data. Now for the add, there are 2 cases. Number 1, case 1, or technically just 2 cases. We have the base case, and then the other case is I'm gonna write it out first. We're gonna have the first case, which is if the list is empty. If head equals null, head equals new node, and new node dot next equals new node. This points to itself. If there's nothing in the list, the head is just gonna point to itself. And that's it. You just return it. Bada bing, bada boom. I also have case 2, where there are things in the list now. So we're just going to call it non-empty list. And with this one, what we're going to do is we're going to find a tail. Alright, there's no need to comment that. I'm just going to explain it. So with this one is if you want to add something and you want to add it towards the end, you want to find the tail first and then just add it towards the end, you know? So cnode temp equals head, and then while temp dot next is not equal to head, temp equals temp.next. And then temp.next equals new node. Think of this as like an old tail points to new node. And then the new node dot next is going to become the head. So new node points back to head. And that's it. So for example, we have 100, 200, 300, and then we want to add the 400. We're going to find the tail first, which is 300. So, and again, while in order to do that, we're going to go through it. So while temp.next is not equal to head, meaning 300 or 200 was not pointing to head, we keep going. Now 300 is going to be 300.next is going to be pointing back to head. Then the while statement is gone, is over. Now we're at the tail. And what we do is we're going to have the temp.next equals the new node that we're going to add in. And then the new node.next will be pointing to head. So we add the 400, and then the 400 pointer is going to be pointing to head. That's it. Very quick, very simple. Next up, let's continue forward with the next one, which is print the circular list. And we're going to do it once around the circle. Public void print list. Oh, there we go. Again, with this one, you just write it out the base case, which is very simple. If head equals null, meaning there's nothing. Oh, Jesus. Okay, there we go. We're just going to print out empty. Or you can say circular list is empty. Doesn't matter for me. And then you just return. Now, moving forward, we have temp. See no temp. And we're going to have that point ahead. Now, we're going to do the do while, which was the one I mentioned before. You want to use this way, it goes through the list once. Let's print the temp.data and have the arrow key. And then we're going to have temp equals temp.next. And you're going to do that while the temp is not equal to head. Then lastly, you print out either the value of the head, or you can just say back to head. Because I'm going to do back to head because it's a lot simpler to sort of like, when you look at it, you sort of just understand that, oh, the circle is now, the pointer is now back all the way back to head, you know? And so now and that's it for the print. Very simple as well. Let's do the next one, which is going to be delete the node. Or we're going to, in a way, it's like you want to delete the first node that it encounters, like whose data, you want to delete the first node whose data is equal to value, right? So public void delete by value, and we're going to have value, or sorry, int value. Gotta make sure it's integer. Inside we have, now this one's a very interesting one because we will have 4 cases for this. The first case, again, is the base case in case the list is empty. Now we're going to have C node. We're going to call it current, and that's going to be pointing to head. Now, case number 1. This case is in case there is only one node in the circle. And it is exactly the node that we're looking for, which is very simple. If current.data is equal to the value and current.next is equal to head. This shows that there's only, so let's say in the circular list, you only have 100, and that 100.next is pointing towards the head, because that's how circular works. Then in that case, that proves the case number 1, that this 100 is the one we're deleting for. It's the one we're deleting. So when that happens, case 1 works. So head becomes null, and then you just return. That's it. Now let's do the second case, which is how are we going to delete like how are we gonna delete if there's like multiple nodes in the list and we're still deleting the head? So the first one is you're deleting the head, but there's only one node. The second case is you're deleting the head, but there's multiple nodes like afterward. So delete head. In lots node circle something blah blah blah. So if current.data is equal to the value, then first let's find the tail. We need to find the tail because that tail is pointing to the head. So C node tail equals head, and then while that tail dot next is not equal to head, so we're going through tail equals tail dot next. So this one is we have a tail pointer that is pointing at head, and it's just gonna go through the list. Now once it does reaches the tail dot next where it is pointing at head, that is the last node we are at. So when that happens, then the while statement is over, and we're gonna have head dot next. Head equals head dot next. With this one, it means that the current head is gonna become the new head is gonna become like, how do I say this? The head is gonna become the head dot next. So actually this is how you say it. Move head forward. There we go. You just move the head forward. And then after that, tail dot next will become the head. So let's say if I want to delete this 100, I'm gonna go through the while statement, meaning we're not at heads, until we reach 400, when we now realize that the tail dot next will go back to head, right? So when that happens, this 100, which has the head pointer, is gonna go to the next one, 200. So 200 now becomes the new head, and then the tail, which was right here, that tail dot next is gonna go all the way back to the head, which is at 200, the new head. So tail now points to new head, like that. That's how you explain it. There we go. And then you just return, nothing else. So with this one, essentially we're just like skipping over the 100 now. Very simple, very quick. I think I dropped something. Oops. Whatever. Then we're gonna have case 3, which is now the case 3 is the normal. Yeah, case 3 is the normal case where you're just deleting one of the values that was part of that's in the circle, but that value or that node isn't the head. So I think, how should I comment this? Deleting non-head node. So C node prev equals current, and then current equals current dot next. While the current is not equal to head, if current dot data equals value, then prev dot next equals current dot next. So think of this as like a bypass current. You're just skipping over the current, and then you return, and then prev equals current, and then current equals current dot next. That is it. So this one, very easy. There's not much I needed to do with explaining this. Very quick, very simple. All you're doing is you're just skipping over. Now, I think that is pretty much done with the delete by value. So we're gonna do the last one, which is search for a value in the circular list. We're gonna have public, and it's a Boolean, search int value. This one, you're just searching it. If the value's there, print out true. If it's not, print out false. Again, base case, if head equals to null, meaning there's no value for you to find, then you print out false. Base case, always. C node, temporarily, temp equals head. We're gonna do if temp.data is equal to the value, return true. You found the value, perfect. And then temp equals temp.next. And this is all happening while the temp is not equal to head. If none of that happened, then you return false. Very quick, very simple. And I have all the case written down here. So let's test it out. Okay, what we have here is I added 100, 200, 300, 400. Print out the list. So there we go. It's going to print back to head, meaning it's going to go back to 100. And I decided to delete the value of 200. Boom. This is what happens after you delete the 200. The 100 pointer is going to point at 300. And that's it. You print the list out. And then the next one, the next one, search. Is there a 300 value in there? Yes, there is. Print out true. Is there a 999? No, there isn't. So it prints out false. Now, let's say if I want to delete, or let's say if I want to search the 200, right? Since the 200 is deleted, because I removed it from the value, it should print out both false. Or like that. You get the idea. So it'll print out false for the 200 as well. And there we go. Perfect. And that's just the basic circular list. Yeah, that's it. Thanks for watching. But the next one, I'll probably start working on. I'll try to see if there's any LeetCode problems with circular, which I'm pretty sure there is. So, all right. Thanks for watching.